Hello there, and welcome back to the channel. Well, yesterday I talked a little bit about cooperating and sharing with students their experiences online and how they're doing their work with online resources. Today I want to address an issue that's been bothering me lately, and I want to talk about it in a way that I hope will be useful to someone. We're hearing a lot now about AI, meaning artificial intelligence. And my first objection to it is I don't think it should be called AI. I think it should be called machine learning. Here's why. AI, or artificial intelligence, gives the impression that it's an intelligence, a personality, an individual. That what you're interacting with is a conscious being. That's the impression it gives. It is not that. It's machine learning. So I want to back up a little bit and talk about computer programming, and I will offer here right now that I have only a rudimentary knowledge of how the AI systems are designed. But I think it's important that I share with you some of the things I know and try to illustrate why it is dangerous to think of these programs, these machine learning programs, as a type of cognitive substitute. It is not a cognating thing. It does not think. So let me back up a little bit in the programming world to when I was programming and to what I discovered about the programming world at the time when I was thinking about entering it. So I learned basic in Fortran, some of the very rudimentary languages of machines. And one of the things that we were developing in our classes were systems that are designed to data crunch, because data crunching is where human beings are nowhere near as effective as machines. We, by our very nature, we make mistakes, and machines are less likely to make the same type of error as a human is. So we were designing these programs to, for example, one of the programs I wrote in Fortran was a program about billing, how you would have the machine compile the data from a group of customers and generate bills for those customers to be sent out. Now, it was a fairly simple program to write, although even at that time, the challenges of writing those programs were pretty important. For example, you did still have to enter the data as a person so that the program could generate the bill. Now we have systems where machines provide the data, but at that time, a human had to provide the data. And so some of the things that the program would do is it would prompt the user to enter the number of kilowatts that somebody. So a person would have to enter the data, like the number of kilowatts a customer used in their electricity in their home for a month. And what I was interested in was, in those interactions, could you prepare the computer for a person to make a mistake? So for example, if it prompted the person to put in a number and the person typed in a letter, what would happen to the program? Well, so if you did that without putting in a check system within the program would just basically go blank because it couldn't progress from there and it didn't have a response to that. So those kind of little checks had to be put in where the program would look at what the data was entered, and if it was a correct type of data, it could go on to its next step. And if it wasn't a correct type of data, it would loop back and ask the question again, or ask a question similar like, I need a number, not a letter. Okay? So I was interested in that part. I was interested in the human interaction part. But at that time in programming, human interaction and human psychology did not matter as much. It was still so rudimentary, essentially. that they were just trying to figure out how to solve problems and write programs that would solve problems. But even then, they were working with machine learning that was designed to be self-perpetuating. Like they wanted to design a little robot that would go around and feed itself when its battery got low. Like know to plug in to a wall and recharge when its battery got low. So that's the kind of that's how long machine learning has been of interest to programmers. It's always been of interest to programmers. So meanwhile, I was in psychology and realizing that human psychology was a really, really potent design consideration. So for over a century, human beings have been using human psychology to find ways to make money off them. And one of the places that we studied when I was in psychology was Vegas. So it turns out that human beings like pretty lights. They're kind of like a reward for humans. And certain types of musical sounds are a reward for humans. It makes them happy. It gives them pleasure. And so the people who ran casinos came up with the slot machine, also called the one-armed bandit. And for people who've never seen an old-fashioned slot machine, it had a lever on the side that you would pull, and these tapes would spin, and you might win money. You put money in to spin the lever, and you might win money if the right symbols came up. And what psychologists discovered was people will pay money for money at a remarkably and almost addictive level. And the reward, even if it's not as much as you're putting it in, feels like more. So for a long time, I don't know about Vegas now, but for a long time, the biggest money makers in Vegas, all told, were the slot machines, because people would be hypnotized by them. They would plug money into them, and they did not have to pay out more than they got. They were guaranteed to pay out less, but it was so random you couldn't predict when the payouts would come. So sometimes you get a big payout, sometimes you get a little payout, but in the end the machine always kept more than it gave. And in fact, that came to be regulated because it was such an addictive machine that regulators said, you've got to pay off X amount to people that are playing because that's only fair. You're addicting them to this machine on the promise that they can win, and they're not winning. So this was something that was in psychology even that far back. The same understanding of our human inclinations has gone into the design of machines we use all the time. The computer, and especially our cell phones and tablets. So they're designed to be beautiful, attractive to us, and to provide us with pleasure and entertainment. They're designed to get us addicted to them. The games people play are designed to entice them in. And almost everything has been turned into a money-making system. But the reality is machine learning is absolutely not like human learning. It is data-driven and it's statistically driven. So when you put in a question to an artificial intelligence system or a machine learning system, the machine has scraped all of the information available on the internet and this does a statistical analysis and gives you the most likely answer. Now the thing is, there's a lot of information out there that we know somebody knows, and when we ask the question, we're really just looking to find out something that we know somebody knows out there. And so the machine gives us an approximate answer, okay? So that's why it's so right all the time. And if you extrapolate out from that, when it's writing papers, academic papers, what it's doing is it's scraping all these academic papers that it has available. You give it the parameters and you give it the command, and it approximates something close to that. All right? It will never innovate. It will never discover something new, because that's not what it does. It's an approximation machine. It's a data scraping approximation system, DSAS. And a DSAS, it can't provide you with an original thought. It can only provide you with things that you ask it for, that it can compile statistically for you. And this includes images. That's why it's so much fun to play with these images that the computer generates at your command. Your command is the innovation. Show me a cabbage with a face like Donald Trump. That's your innovation, and it will take the data from all the art that's available online, all the photos, all the artistic images. It will take them and create an approximation of what you're asking for and give it to you. But it's your instruction that is the innovation. The craftsmanship is all stolen from other humans. It is not an innovative thing. That's why it hallucinates, because there's things out there that are false or wrongly derived or wrongly written or falsely written, and if there's not enough other stuff to make that not enter the approximation, then it does. When we think about machine learning and machine systems, we need to think about them in the sense of data handling. They're always going to be better than people because they don't forget, and people do, and because they don't invent, and people do. What they approximate is what's available, and what's available is what comes from people. There is no motivation inside that machine learning, that data scraping device, that approximating device. There's no motivation, there's no innovation, there's no creativity. It's just kind of close to what you like. So, or what's right. And that's why a lot of times it's right, because there's a lot of very good information available, and it's just making educated guesses. But in the end, it doesn't have an individuality to it. There is no identity there. There is no cognition there. There is only data and approximation there. It is not smart. So it's not intelligent. So it shouldn't be artificial intelligence. It should be machine learning or DSAS or something else. But we should never think of it as a conscious and alive thing, because that's not in the power of the programming to make. That's not available to us. And the thing is, in medicine, the reason why this is so useful is so much medical work has been carefully done and then recorded and shared on the internet. There's so much material available for the machine to approximate with that it can be really useful, because it's about data. It's about gathering that data and forming models. And then the scientists can decide which of these models work. They can do experiments to see which of these models are best. That's why it's exciting in medicine. It's exciting in law because there's so much law out there online available. There's so much law, and it can crunch the data and list the cases that very likely a law student might not know about or might not remember. But see, the thing is, it can't forget, and you would think, well, that's a strength. But it can't be a strength, because we're made to forget. There must be something important in that. We're made to behave. There must be something important in that. And above all, we are created with the ability to see fairness, which no machine learning can spot. We're created with the ability to care about others. Machines do not care about others. That's just not the way it works. Big Hero 6 is wonderful and lovely, but that machine is not a real machine. That machine is a being. And love is not created by approximation. It's divine. There is no compassion in machine learning. There is no invention in machine learning. There is only approximation. I hope that's of use to somebody. I know that it seems all very mystical because many of us don't program anymore or have never programmed, and so we don't really consider what some of the things they're talking about might reflect in reality. And that's why autonomous vehicles are dangerous. It's not because they might suddenly decide to turn on us. That's not the scary part. The scary part is they're vulnerable to being hacked by somebody who has already turned against us and will use a machine to do evil that they choose to do. They will give it the instructions to do awful things. And that's what's really scary about these autonomous systems. That's it for today. I hope you have a lovely day. And I hope you tune in tomorrow when I'll be reading from The Hitchhiker's Guide to the Galaxy. Hope you see me again soon. You gorgeous people.